let's take a look at a couple other types of exponential or logarithmic equations. And so this first example involves a quadratic-like expression on the left. And in that case, we may need to factor. And so the first thing I want to recognize is how the powers relate to one another. And we can see that the bases are the same, but the exponents are different, and we also notice that the first exponent is twice the second. Okay, so if that happens, we're going to do a substitution method. So we're going to say let a equal whatever the smaller of the two powers is. So in this case, it's 2 to the x. And then we're going to replace 2 to the x in the equation with a. And so we get 2 to the x, so that would be a squared, because we could write 2 to the 2x as 2 to the x to the second, and then substitute a for 2 to the x. Okay, so we have a squared minus 5a plus 4 equals 0, and now we can factor this quadratic expression. Okay, so we have a minus 4 times a minus 1, and then we're going to set each of these factors equal to 0. So a minus 4 equals 0, or a minus 1 equals 0, and solve for a. Okay, so in the first equation, a is 4, and in the second, a is 1. But notice when we're solving the original equation, we're solving for x, not a. So now we're going to resubstitute. We're going to replace a with 2 to the x. And we find two equations. 2 to the x equals 4 is the first one. 2 to the x equals 1 is the second. And because these are easy enough to hopefully compute in our heads, we can do that. If not, you could use a logarithm to solve. This is x equals 2, and then the second is x equals 0. So altogether, we have x equals 0 or 2 as the solutions to the original equation. And we can solve logarithmic equations by converting them to exponential form. And recall that if y is equal to log base b of x, then b to the y is equal to x. And so for this first example, log of 4x is equal to 2. Recognizing that the base of this logarithm, it's a common log, the base is a 10, we convert to exponential form as follows. So 10 to the second is equal to 4x, or 100 is equal to 4x, and dividing both sides by 4, we find that x is just 25. In this next example, negative 4 plus 2 times natural log of x is equal to 1. So isolate the logarithm, and the first thing that we'll do is add 4 to each side. Okay, so we have 2 times natural log of x is equal to 5, and then divide both sides by 2, and we find that natural log of x is equal to 5 halves. At this point, we're going to convert to exponential form. And remember, the natural log has a base of e. Okay, so starting with the base, e, we're going to raise it to the 5 halves, and that is equal to x. So an exact answer is e to the 5 halves. An approximate answer is about 12.18. And let's take a look at one more example. Log base 2 of x plus log base 2 of x plus 6 is equal to 4. So the first thing that we want to do is to combine the logarithms, write as 1 if possible. And so if you remember, our product rule says something like this: log base b of m plus log base b of n is equal to log base b of m times n. So on the left side of the equation, we'll get log base 2 of x times x plus 6 is equal to 4. And if we rewrite this in exponential form, we start at the base. 2 raised to the 4th power is equal to x times x plus 6. Okay, and we simplify. So 2 to the 4th is 16. X times x plus 6 is x squared plus 6x. And now we have this quadratic equation that we're going to try to solve. And one possible option is factoring. So we'll move the 16 to the right-hand side, so we get x squared plus 6x minus 16, and try to factor. Okay, so factors of negative 16 that add to give us 6 are positive 8 and negative 2, and then set each of these factors equal to 0. So either x plus 8 is 0, or x minus 2 equals 0, and then x is either negative 8 or x is equal to positive 2. Well, one other thing we have to be careful about having an extraneous solution, which is a solution that really doesn't work in the initial problem, but these two definitely solve the quadratic equation that we found. And so recall that one of the properties of logarithms is that the argument is never negative. So substitute the values of x that you found into the original equation and just ensure that they work. Negative 8 does not work for that particular argument, but 2 would. And so our answer is just x equals 2.